Hello dear students, my name is Dr. Vaishali Ghai and the name of this channel is Tricks by Chemistry Guru. So today we'll talk about redox reaction for class 11th. Before going to start with the introduction part, I'll tell you redox is a word that consists of two words, reduction and oxidation. It consists of reduction and oxidation. It means a reaction in which both reduction and oxidation takes place. We call that reaction as redox reaction. Now the thing is what an oxidation is. How can we define oxidation? So there are certain points that it very well explains oxidation. One thing is where we say that a reaction which involves the addition of oxygen, we call it as oxidation. If suppose oxygen is not been added, I can write addition of any electronegative element is also oxidation. I can write removal of hydrogen is also an oxidation, or removal of any electropositive element is also oxidation. This is basically a classical idea or the earlier concept of oxidation. Along with this, we have one more, that loss of electron also involves oxidation, and increase in oxidation number is also an oxidation. Then what reduction is? That means any of this point, if observed in any of the reaction, we call that the substance undergo oxidation. Now the thing is what reduction is. So if I ask you what reduction is, here since it involves the addition of oxygen, I can write here is the removal of oxygen. So any reaction in which an element removes oxygen, that substance undergo reduction. Removal of oxygen, removal of electronegative element. Or here this case we have observed removal of hydrogen, reduction is reverse of this. So I can write addition of hydrogen is observed in reduction. Addition of electropositive element is reduction. In oxidation we observe loss of electrons, so in reduction we observe gain of electron is reduction. And sixth point is here we have observed increase in oxidation number. Here I can write decrease in oxidation number. What are these? We'll discuss one by one and I'll give example for each case. These are the points of differences. The first 4 points are the electrical or the earlier concept, the classical concept for oxidation and reduction. And last 2 points basically are the latest concept in terms of electron, in terms of oxidation number. So let us discuss few cases. Like if I have written addition of oxygen. So if I have written addition of oxygen, let me write one reaction. C plus O2 gives us CO2. So C undergo oxidation because it adds oxygen to it. C का हो रहा है oxygen. Concept is addition of oxygen. So this is oxidation reaction. Then second is addition of electronegative element. Suppose I am having Fe and I add Cl to it. It becomes FeCl3. So addition of electronegative element to iron, and thus iron undergo oxidation. So electronegative element is chlorine. So in first case we have seen addition of oxygen that causes oxidation. Second case we have seen addition of electronegative element causes oxidation. Third is removal of hydrogen. Suppose I am removing hydrogen from any reaction. I have taken H2S and add Br2 to it. H has been removed from sulfur, we get HBr and sulfur comes out. So it is removal of hydrogen from sulfur. Sulfur removes hydrogen. So removal of hydrogen from sulfur, so I can say sulfur undergo oxidation. Similarly, removal of electropositive element. So suppose I am having a reaction of Ki. I add H2O2 to it. It changes into I2 and KOH has been added. So removal of electropositive element. This case the electropositive element is potassium that has been removed from iodine. So iodine undergo oxidation. So from point number 1 to 4 I have explained what oxidation is. Now we'll discuss what reduction is on the basis of these points. So first thing is removal of oxygen. Let us take an example ZNO, which is added with any reducing agent, say carbon or coke, and forms zinc. So removal of oxygen from zinc, so zinc undergo reduction. Next, removal of electronegative element. Let us take the reaction reverse of this one. And it is mixed with H2. It becomes FeCl2 plus HCl. So FeCl3 added to H2, it changes into FeCl2 and HCl. We can see the removal of electron negative element, that means chlorine from iron. So iron has removed one chlorine from FeCl3, it changes into FeCl2. So one chlorine comes out and thus it undergo reduction. Next is addition of hydrogen. Let me take N2 plus H2 gives us NH3. So nitrogen involves the addition of hydrogen, so nitrogen undergo reduction. Addition of electropositive element. Now after this basic definition of oxidation and reduction with their examples, now we'll move what oxidizing agent is. So when we talk about oxidizing agent, we say that any substance which oxidizes others and reduces itself. That means the substance itself undergoes reduction but oxidizes other. We call it as oxidizing agent. Whereas when we talk about reducing agent, it is reverse of that. So in reducing agent, we say that a substance which reduces others and oxidizes itself. We call it as reducing agent. That means the thing is oxidation and reduction. Both these reactions, they go side by side. Both these reactions go side by side. Oxidation and reduction both go side by side. So it's been observed that a redox reaction is that reaction in which both oxidation and reduction takes place. Suppose I'm talking about a reaction. I'll take ZNO and add carbon to it. It changes into zinc plus carbon monoxide. In this case, we have seen that the reaction takes place, zinc loses its oxygen. So removal of oxygen takes place. So it is zinc which undergo reduction. At the same time, carbon adds oxygen to it. So it is carbon which undergo oxidation. So carbon undergo oxidation, zinc undergo reduction. This complete reaction is known as redox reaction. So you can see that both reactions, when both oxidation and reduction go side by side, we call the reaction as redox reaction. Now, I have given one definition in terms of electron, that loss of electron is oxidation. Let us take any metal which can lose electron. So sodium loses electron. It undergo oxidation. Iron loses electron, undergo oxidation. Similarly, if we talk about gain of electron, chlorine, it gains one electron, becomes chloride ion. So gain of electron is reduction. Oxygen gains 2 electron, forms O minus 2. So gain of electron is reduction. So this is the example of oxidation reduction in terms of electrons. So now in general we can say oxidation involves the loss of one or more electron. Reduction involves gain of electron. And what is oxidizing agent? The electron losing species. जिसका ऑक्सीडेशन हो रहा है वो रिड्यूसिंग एजेंट है, जिसका रिडक्शन हो रहा है वो ऑक्सीडाइजिंग एजेंट है. सो आई कैन से वन विच लूजेस इलेक्ट्रॉन acts as reducing agent. One which gains electron acts as oxidizing agent. Clear? So this is about the general definition of oxidation reduction in terms of electrons. Now we'll talk about electron transfer process. Suppose I'm having Na. It adds chlorine to it. We get NaCl. Na changes to Na plus and Cl changes to minus 1. So we have seen that sodium changes to plus 1. That means it loses electron. So it loses electron. It undergo oxidation. Chlorine changes to minus 1. It means it gain electron. So it undergo reduction. So this way we can see that it is an electron transfer process that makes completely a redox reaction. So I can say that sodium in this case, which undergo oxidation, is reducing agent, whereas chlorine acts as an oxidizing agent. This is how the reaction takes place. That means if I consider only oxidation in this case, so I can say sodium changes into Na plus, and if I consider only reduction, I can say chlorine changes into Cl minus. So this is how the oxidation and reduction takes place. We call these reactions as half reactions. Half reaction means every single redox reaction consists of two reactions. One is oxidation half reaction and other is reduction half reaction. Oxidation half reaction and reduction half reaction. That means I can say that a redox reaction consists of, a single reaction consists of two half reactions, like Na changes into Na plus, that is oxidation half reaction, and Cl changes into Cl minus, that is that is reduction half reaction. So this is how we can easily identify which species is including oxidation and which species includes reduction half reaction. Clear? Now after this we'll talk about, I'll give you one reaction and you just tell me how the reaction takes place. Suppose I'm having this, the loss of electron including zinc, and I'm taking H ion which gains electron and it forms H2. This is here loss of electron takes place, so it is oxidation reaction. This is reduction half reaction. If I combine these two, I'll just get Zn plus H ion. To balance the reaction, I'll be having 2 H ion because here we are having involvement of 2 electrons, so it must be 2 electrons this side also. And Zn plus 2 on right side, these 2 electrons get cancelled and H2. So this is complete redox reaction that is formed of two half reactions, oxidation half reaction and reduction half reaction, and we finally get redox reaction. Oxidation half reaction and reduction half reaction, finally we will get redox reaction. Let us talk about any displacement reaction. Zinc loses electrons to form zinc ion. Copper ion gains electron to form copper metal. This is, it undergo oxidation because it includes the loss of electron. This undergo reduction because it includes the gain of electron. If I combine these two, I'll get Zn plus Cu plus 2, reactant of both half reactions, then product of both half reaction, and these electrons will cancel out. So Zn plus 2 plus copper. So if we see this reaction, this is complete redox reaction. In this case, we have seen that zinc undergo oxidation by the loss of 2 electron and copper ion undergo reduction by the gain of 2 electron. So these two are two half cell reactions, oxidation half reaction and reduction half reaction, and in combined form we have complete redox reaction that includes oxidation half reaction as well as reduction half reaction. So this all about is the basic introduction. We'll continue in the next class. Thanks for watching. Please subscribe the channel.